FastMCP 2 employs dependency injection to manage runtime values, allowing tools to declare dependencies as parameter defaults while keeping client-facing schemas clean. This mechanism automatically resolves and injects values like CurrentDocket, CurrentWorker, and progress during execution. The upcoming code demonstrates how to initialize a task-enabled tool that reports progress through atomic updates, using injected dependencies to track completion state without exposing internal mechanics to clients.
From FastMCP, import FastMCP. From FastMCP dependencies, import CurrentDocket, CurrentWorker, progress. MCP equals FastMCP task demo. At MCP, tool task equals true. Async def long-running task. Data, SDR. Docket equals CurrentDocket. Worker equals CurrentWorker. Progress equals progress. SDR. Await progress, set total 100. For I in range 100. Hash process chunk. Await progress increment. Await progress, set message if processing chunk I plus 1. Return complete.
This code demonstrates FastMCP's task progress reporting system for long-running operations. The long-running task function is decorated with @MCP tool task equals true, marking it as a background task that can report progress to clients. The function uses 3 injected dependencies: CurrentDocket for task coordination, CurrentWorker for worker information, and progress for progress tracking. The progress reporting follows a clear pattern. First setting the total work units with set total 100, then incrementing progress with each iteration while updating the status message. This atomic update approach ensures clients receive consistent progress information. The progress dependency handles the underlying protocol communication, abstracting away the transport layer details. This pattern is particularly useful for operations where clients need visibility into execution status, such as data processing pipelines or batch operations. The dependency injection approach keeps the function signature clean while providing access to the full task context. The trade-off is that task-enabled functions require the FastMCP tasks extension and can only use these dependencies when task equals true is set. Let's break it down.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol MCP servers.
From FastMCP dependencies, import CurrentDocket, CurrentWorker, progress.
Imports 3 FastMCP dependency classes: CurrentDocket for accessing the CurrentDocket instance, CurrentWorker for worker information, and progress for task progress reporting. These provide runtime context and progress tracking capabilities within FastMCP tasks.
MCP equals FastMCP task demo.
Creates a FastMCP instance with the server identifier, task demo, that will be used in MCP protocol handshakes for client identification. The string parameter serves solely as a label and doesn't configure any functional behavior or operational mode.
At MCP, tool task equals true.
Decorates the following function as a FastMCP tool that can be invoked as a background task. The task equals true parameter explicitly marks this tool for asynchronous execution, enabling progress reporting and dependency injection via Docket.
Async def long-running task.
Defines an asynchronous function named long-running task that can be awaited and will execute as a coroutine, allowing other operations to run concurrently while it processes. The opening parenthesis indicates parameters will follow, though none are visible in this segment.
Docket equals CurrentDocket.
creates a parameter named docket, initialized with a new instance of CurrentDocket. This provides access to the CurrentDocket context, enabling dependency injection and task coordination within the function.
Worker equals CurrentWorker.
Creates a variable named worker that holds the result of calling CurrentWorker, which retrieves the CurrentWorker instance in the FastMCP context. This provides access to worker-specific information or functionality within the task execution environment.
Progress equals progress.
Creates a progress instance and assigns it to the variable progress. This initializes a progress tracking object that can be used to report task progress back to clients in FastMCP's task system. The empty parentheses indicate it's instantiated with default configuration.
Await progress, set total 100.
Sets the total progress units to 100 for the current task's progress reporter. The await indicates this is an asynchronous operation that will complete before proceeding.
For I in range 100.
Initiates a loop that will execute the indented code block 100 times, with the loop variable, I, taking integer values from 0 to 99 in each iteration.
Await progress increment.
Increments the progress counter asynchronously, advancing the task's progress state by 1 unit. The await keyword indicates this operation is non-blocking and returns control to the event loop while waiting for completion. This line assumes progress is an object with an increment method that supports a sync await syntax.
Await progress. Set message if processing chunk I+1.
Updates the progress message to indicate processing of chunk number I+1, where I is the current iteration index. This asynchronous call modifies the visible progress state for the client, providing real-time feedback during chunked processing operations.
Return complete.
Returns the string literal, complete, as the result of the function or operation. FastMCP2's dependency injection system elegantly handles runtime values while maintaining clean client-facing schemas. The long-running task demonstrates this by using injected dependencies, CurrentDocket, CurrentWorker, and Progress to manage task coordination and progress reporting without exposing internal mechanics. The progress dependency abstracts protocol communication, allowing atomic updates via setTotal, increment, and setMessage, ensuring clients receive consistent progress feedback. This pattern is particularly useful for operations requiring visibility into execution status, like data processing pipelines. The trade-off is that task-enabled functions require the FastMCP tasks, extension, and can only use these dependencies when task equals true is set. The dependency injection approach keeps the function signature clean while providing access to the full task context, showcasing FastMCP's ability to balance simplicity and functionality.
The task whispers to progress, while the loop hums, counting chunks that vanish into completion.